In this section, which seems like a bit of a repeat of something we've done before, we go over inverses of functions, and so here's a couple of questions from the book. Explain why we cannot find the inverse for all polynomial functions. Well, to have an inverse, you have to have the function being 1-to-1, and obviously in this first example, you can see if I draw a line in the horizontal line, it's not 1-to-1 because it doesn't pass the horizontal line test. Why must we restrict the domain of quadratic functions when we find its inverse? So again, it's not 1-to-1, so we can't have an inverse, because when we go back, then our inverse is not a function. But if we restrict the domain to just one side or the other, so like if I restrict it to the positives, then it becomes 1-to-1 and we can have an inverse. Similarly, if I restrict it to the other side. Now notice that the point here where we're restricting it is the vertex, or the turning point. All right, so let's do this problem number 6. F of x is equal to x squared plus 2 squared on the interval -2 to infinity. So one of the ways we do this is we just have to put a y in here, switch the letters, and now solve for y. So I take the square root, but there's two choices. Now, which one do I choose to use? Well, since I'm defining this on the positive interval, so that would mean that I'm at -2 here, and my interval is to the positive side, I'm going to use the positive square root. Then I just subtract the 2 over, right? So I get -2 plus square root of x equals y. Rewrite the y in inverse notation, and we get -2 plus square root of x. And that gives us our inverse function. All right, so let's try number 9. F of x is equal to 3x squared plus 5 on the interval -infinity to 0. So again, I can just put y in for the f of x, switch the letters, now solve for y. So I subtract over the 5, divide by 3, now take the square root, plus and minus. Now, because this is the negative side of the parabola, we're going to go with the negative one. So we have, and since there's nothing more to do other than just switch it, we're going to get f inverse is negative square root of x minus 5 over 3. And we have our inverse. All right, so let's try number 18. F of x is equal to the square root of 3 minus 4x. So one of the key things we have to be careful of is about domain and range. But remember, the domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. So kind of the key thing here is we know what this domain is just by what's natural, right? We can just say 3 minus 4x has to be greater than or equal to 0. Subtract 3 over to the other side, divide by a -4, and we switch this around, we get 3/4. So we know that the domain, which is the range of our original function, is -infinity to 3/4, like this. Now, what is the domain? Well, all that's going to come out of this thing is positive values, because the graph actually looks like, what happens? This thing, we know it shifts to the right and flips around. So here at 3/4, we get the original square root look like this. So this thing is going to flip around this axis and then slide over. So it's going to look something like that. So we know the inverse is going to be 0 to infinity. Now that's going to be the restriction on our inverse function. So let's find the inverse. So I replace the f with y, and then switch the letters around, Oops, that's a y. And then square both sides, because I want to solve for y. Subtract 3. Divide by -4. So I have... And now I can replace with the inverse notation, which means that I get -1/4 x squared plus 3/4. So this thing is going to have a domain, like we said up here, of 0 to infinity. Alright, and then it's going to have a range of -infinity to 3/4, because if we want to graph what this thing looks like, this -1/4 flips it around the axis, and then that moves it up. So we're getting something like this. We're ignoring that piece, but we're getting just this one. So this is our inverse function. That's the graph of it, like that. Not this half of the parabola, because we've restricted the domain to that.